The first thought of the robot is that it's very easy to build. If we assume that we attach the pins to the cup, the motor goes on the top. I suppose we can find a place for the battery where they fit best and do not cause the cup to fail over because of the balance. You could say that it can be inside the cup as well, but the weight of the battery will be heavy and blocks the movement of the toy robot. I'm convinced that if the battery and the battery holder were in the top of the cup, the weight will be centered in the middle. Not necessarily it would work, but it might be a reasonable solution. For the wooden stick for the legs, we did not expect that we need 3 legs. We thought we just need 4 pins attached to the cup, but the weight of the 4 pins obstruct the movement of the motor. I'm confused that we can adjust the line smoothness by trying different rotate weights and weight position. It had exceeded our expectation that we have to solder the battery holder wires with the motor. The process of the soldering was extremely well because of our engineering background of the soldering. Since the battery holder and the motor are actually smaller, it's make mounting them to the cup easier, but the speed of the motor caused the wire to be cut and we soldered it again. We faced another problem with the battery holder, that the wire cut from the inside, so we replaced it with another battery holder. But it did not go exactly right because of the weight of the box was very heavy, and it prevent the movement of the motor. So we decided to fix the old one by taking off the upper side of the holder and solder the wire to the inside part, so the heavy weight of the battery holder fixed. The rotation required the torque at each joint lifting weight, so the motor can move. Finally, we agree that the robot is built by using a plastic cup, wooden stick for legs, and 1 pin for a support. A motor is attached to a 3-volt battery clip, which is attached to the top of plastic cup. Two 1.5-volt batteries are needed to power the motor. The robot should draw a circle and then walk on a straight line as possible. The different types of drawing needed to build our robot are elevation, exploded view, and cross-section. Cross-section are cut through something. Elevation is a perspective of different angles, and exploded view show the relationship of variable parts. We have chosen the exploded view and elevation drawing because the description of drawing suit the robot, show how to build it, and we will fully understand them, but the other drawing will be not useful.
The elevation drawing of our robot shows the outer appearance of the robot as the person looks directly at it. It shows the robot from different perspectives like the sides, front, and above. This drawing is essential because it tells us how to build the robot and where is the right place to set each piece of the robot. It also shows the dimension and the distance between the parts. I think when we will place the wooden sticks on the cup, it will be hard to know exactly where to place them or how to determine the place that will make them in an equal place on both sides. The other problem is with the propeller. It should be away from any part to let it move without any collision.
The exploded view is a drawing that shows the individual part of the toy robot separately. Exploded view are useful because detail can be seen. Parts are not hidden behind other parts. We can see the wooden stick, battery, the battery holder, and the entire part of the toy robot. It helps us to turn the motor so that axis shows sideways, and how all the pieces gather to form the final toy robot shape.
We could say that our robot has the ability to draw large precise circles with a good speed, although that it shakes a little bit. We can say that the reason of the shake is the propeller. The robot needs a straight floor without cracks to move on it. The speed of the robot on drawing the circles depends on the battery. Whenever the battery is working well, propeller will work fast. Then the robot will draw faster. The robot is able to draw perfect precise circles if a straight floor is available. Any movement while the robot is working or drawing causes a defect on the circle. We expect that if we put the battery holder in the cup, the robot will work well. But it was the wrong idea. Putting the battery holder inside the cup made it heavier and harder to move, so we put it above the cup. The path that the toy robot takes can be adjusted by changing the angle of the wood sticks. To redesign the robot, we remove the propeller and add tires with a friction motor. The cup interfaces to the base that holds the tires and the motor by two pencils and one wooden stick. We use the glass ball and place it on the plastic base. The glass ball is useful because it provides balance insurance. Although that the robot doesn't move straight forward, it moves fast and in a straight line for seconds, then bends to the straight side little bit. To sum up, the quality of the robot is great, but consuming the robot a lot might cause some damage on the motor. In constructing the robot, we took care of the aesthetics by adding the robot head. The face of the robot is a serious face, and it gives an impression of a real robot.
Safety standards require goods to be compliant with a particular performance and design. The toy robot follows the safety standards that are designed for a 7-year-old child. The safety standards ensure the safety of the toy robot. The robot does not have sharp edge that would hurt the child when it contained the pins. But when we redesigned the robot, the sharp edge was in the plastic between the tires. If the toy robot breaks down, it won't have a small part that come out of the toy and that prevent the choking hazard. The only hazard in the toy robot is a small motor propeller. It can hurt the child's skin, but it won't be much hazard because it cannot cut the child's skin, just a temporary pain. The robot typically performs a specific requirements task to improve the quality needed for a 7-year-old child user, regardless of the age and the ability.